Let's take a look at factoring the difference of squares. So notice this word difference. Difference is subtraction. And on each of these, notice it involves subtraction. We don't see a middle term, and we see a negative C value, which is that minus sign, that difference. And now squares. So recall that a number that is a square, let's see, 25 is a perfect square because it equals 5 squared, 5 times 5. We can also say, let's go 49. 49 is a perfect square because it is 7 squared, 7 times 7, so 49 is a perfect square. And don't forget too, if you take the square root of 25, it equals 5. If you were to take the square root of 49, you'd get 7. You can also do, let's do 1. 1 is a perfect square. 1 squared is 1. Square root of 1 is 1. So those are just a few examples of what it means to be a square, a perfect square. So now let's take a look at some examples. So here we have x squared minus 16. Now, from what we've already learned, you know you're going to have a double set of parentheses. It's going to be the product of two binomials. We could even kind of look at it like the previous examples. I know I put my x's in because I have an x squared first. And if my C value is negative, I know my signs are opposite. And now I just need my number. Now again, notice you don't have a middle term. So you could also think of this as, well, what two numbers can I multiply to get negative 16? One would have to be positive, one would have to be negative, and then if I add them, I get 0. Well, the answer to that would be positive 4, negative 4. You can also look at it this way, difference of squares. So we have the difference right there. The square root of x squared is x, and that went in right here. The square root of 16 is 4, and there it is. And again, remember, let's just redistribute to check this out. X times x is x squared. X times negative 4 is a negative 4x. 4 times x is a positive 4x. And 4 times a negative 4 is a negative 16. And now notice what happens right here. Well, that's my 0. My middle term goes down to 0. So these cancel each other out. Let's just jump into x squared minus 81. I'm going to put my parentheses. C value is negative. And now again, the square root of x squared is x, and the square root of 81 is 9. X squared and 81 are squares. They're perfect squares. So let's drop those values in. So that means I'm going to have an x here, and then I'm going to have 9. And again, if you were to redistribute that, you're going to see your middle terms are going to cancel out. Now this one, we have a leading coefficient of 9. It's not 1. Same process. 9 is a perfect square, and 1 is a perfect square. So let's put in our parentheses. C value is negative, plus minus. And again, so now let's look at this. The square root of 9x squared. Square root of 9 is 3. The square root of x squared is x. So that means I drop a 3x in. And the square root of 1 is 1. So there's my answer. Let's just jump right into this one. My parentheses, plus minus. The square root of 16x squared is going to be 4x. The square root of 9 is 3. And we are factored. Now let's take a look at mixed factoring methods. So on this example, notice that each of these terms can be divisible by 2. So what I want to do first is I'm going to factor out a 2. And I'm going to be left with x squared minus 3x minus 10. And so I factored out a GCF first, and now I'm going to factor this trinomial on the inside. It has a leading coefficient of 1. And so I know here I'm just going to put in my parentheses. I can drop in my x's. My c value is negative, so I know that is plus, minus. Two numbers, when I multiply, I get negative 10, and I add, and I get negative 3. Okay, so negative 10, I'm thinking 2 and 5. Well, 5 is bigger than 2, so 5 would have to be negative, and the 2 would be positive. And let's just test that out. X squared, negative 5x plus 2x gets me the negative 3x. 2 times negative 5 is a negative 10. We are good. Let's take a look at the next one. I can see I can factor out, let's see, I have a 15, a 27, and a 6. All of these terms are divisible by 3. Let's factor out a 3. We're going to factor 3 is the GCF. I'll factor that out first. And I get 5x squared minus 9x minus 2. And now from here, I have an option. I can do the AC method on what's inside, or I can do slip, dip, and slide. Let's do slip, dip, and slide. And here, this is another good example. If you were to jump into slip, dip, and slide here and not factor out that GCF first, that GCF would end up getting reduced out and you end up with incorrect factors. So let's take a look. If I do slip, dip, and slide, I'm going to do it on what's within these parentheses. I'm going to slip the 5 at the end. I would have x squared minus 9x minus 10. Keep bringing that GCF of 3 down. Let's factor this. I'm going to drop my x's in. My c value is negative, so I'm going to have a plus minus. And factors of 10 that would add, negative 10 that would add to negative 9, I'm thinking 10 and 1. 10 is the bigger number, so 10 would have to be negative, and the 1 would be positive. So I'd have a negative 10 plus 1 gives me a negative 9. That's good. There we are. So now let's do the dip. I'm going to take this 5 and divide those factors by 5. Where I can't reduce, let's just do it in one step. Where I can't reduce, I'm going to slide the denominator in front of the x, and I get 3 times 5x plus 1 times, here I can reduce, 10 divided by 5 is 2, x minus 2. And there we are factored.